everyone, I am Saniya and today I will be talking to you about the probability threshold. Yes, no, do I make a decision? Do I not make a decision? What is that probability threshold? It's almost like the proverbial straw that broke the camel's backpack. At that point, no matter what, whether you add a straw, whether you add 10 straws, a million straws, luggage, so much stuff, the camel's back is going to break at that point. Even the addition of one straw could make a difference. So that's the kind of the idea of a threshold probability, living on the edge. And what is comfortable to some people, like you can see Homer enjoying it, and Homer's wife Marge kind of being, I'm not too sure. It's sort of like it's very personal. So today we're going to talk to you about the probability threshold, what it is and what it means, and how is it used, especially for clinical decision making, especially in the context of COVID-19 severity prediction. So probability, yeah. So well, what is probability? So probability can be between 0 and 1, and when you typically get probability, it can be given from a model, a predictive model, or it can be given from what you observe. If you are flipping coins multiple times in the air, how many times do you observe that you get, for a coin flip, that you observe that you get heads or tails? Probability is like what we do when we're playing cards, or if we're doing billiards or bowling or shooting at darts or in a casino or playing chess. What are the odds? What are the chances of observing something? So if it's 0%, that means that it's impossible. If it's 1, that means 100%. That means it is certain for sure. If it's 1/2, that means that it's equally likely that it can happen or not happen. Like for a fair coin, you typically expect 50% of the time you get heads, 50% of the time you have tails. So as you go between 0 and 1, the chances of the outcome being observed should increase. So that's sort of like, this is a same night vision versus day vision version of the same thing. And the probability of an outcome is usually given by the number of times you observe that outcome divided by the total number of outcomes you have looked at. So if you flipped a coin 10 times, if 7 times you got heads, the probability of heads would be 7 out of 10, which is 70%. So that's a way to interpret probability, like how likely are certain events to happen. So you can get them from experiments that you've done, like flipping coins multiple times, or shooting a ball into the hoop and observing the outcomes. Or a predictive model can sometimes predict the probability of someone having the disease, and it's usually a value between 0 and 1. So again, this is a probability, so you can represent chance on a continuum. That means like on a spectrum between 0 and 1. And if something is equally likely, we say that it has a probability of 1/2 or 50%. So probability, again, is a chance that some event will happen. So it can be impossible. Then as you move along, the probability increases, and it may be unlikely, a low chance, and then a fair chance, and then pretty likely, and then it's certain. So an even chance is that like it's equally likely for it to occur, like equal chance that you have cancer versus you don't have cancer. And then likely is that something will probably happen or is expected to happen. So in even chances, if you flip a coin or you flip it, it has an equal chance of being heads or tails if the coin is fair. Something that's likely, it's expected. So it's likely that you'll see a tiger at the zoo. Probability is pretty likely. You may not see, it depends on, which zoo or what animals they have or the season or other things going on. Something that's impossible is something that is not able to happen. So the probability is probably 0 or very, very low. It's impossible for it to rain gumballs from the sky unless we have advances in science and technology. And something that is unlikely is something that probably won't happen. I hate to say this, but it's unlikely that you will win $1 million. Win, to keep track of the word win. Hopefully you guys will earn that money, right? You guys are smart, intelligent, trying to learn right now about probability and thresholds, right? So it doesn't mean that it can't happen, but like if you look at the lottery, maybe it might be harder for that to happen. So machine learning, through machine learning, we can build, predictive models, for healthcare, for instance, so we can be able to predict the probability of disease D from patient data. So we can take in all this data, like examination by doctors, inpatient health monitoring, medical imaging, laboratory results, patient-generated health data, and in machine learning, we're just taking all this data. So you can see this little robot is learning, and Geeks for Geeks is a great site. This robot pug is learning how to learn all of this data and build a complicated model that can help us predict the patient outcomes. From all this data, there must be some truth that we can uncover through some data analysis process. So that's what machine learning is trying to do. And based on this data here, they have this training data, and they're going to train a machine learning algorithm and a model, um, you know, and so that when you put in some new data, you have this machine learning algorithm that can make predictions, and then you can manually validate those predictions as well. And this is the other little cat guy over here too. So then when you have a new data set, you can pre-process it, you can train it, and have a machine learning algorithm that you can then use to test your data. So that's what we have here with our machine learning algorithm here. Okay, bye little guy. So you can pre-process it, and then you have your training data, and this robot pug is sort of learning that machine learning algorithm and building a model based on that, so that when you apply new data, this machine learning algorithm that was learned can make a prediction, and the prediction will be applied on new data. So this robot pug has learned all this data from all these different patients that we've collected these different types of data on, and we actually have their outcomes as well, like what actually happened with them. So like in the coronary heart disease outcome, we have all this patient data, blood pressure, and all of that information, and body mass index and actual outcomes, and then we can try to learn an algorithm to make predictions, so that in the future, if there's any patient like that, we can predict what are their probability of having the disease outcome or any situation based on that. That's what the goal is. That's what this machine learning algorithm robot pug is trying to do. Please note that this following example is fictional and is purely used for educational purposes. So disease D is a fake disease, and Saniya fortunately doesn't have it. They don't have it. So this example is helping you guys learn the concepts of probability thresholds, PT. So there's me. I'm a happy-go-lucky person here, Saniya. And you can see the cute little cat over there, May. That's me. I'm happy. It's all good, right? Yeah, man. Yeah. Like, woo, 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 woo. That's me. But then comes the big question, do I have disease D? So I'm worried, and I'm praying, and I'm really scared. And yeah, this is my little temple here, actually. I'm worried, and I'm praying, and I'm so scared. I do not want to have the cancer or the disease D, whatever disease D is. I'm just calling it disease D. And this is also my other god here too. So I'm praying to them. Hope I do not have this condition. So while I'm worried and praying, the doctor is collecting all this information on me. Hi, little guy. And all this information will help me, become like able to collect all this data that will help the predictive model predict the probability that I have disease D. So they're collecting some patient information on me. That's me over here. And they have a patient card that has all this information on me. So it's quite a lot, right? They've taken in some inpatient assessments and diagnostic results. They've run my blood tests and taken my blood pressure and whatnot, and they have all this data here that they can use to train a model here. And that's me, and they have my patient card. So in our case, so this is robot pug here, right? So there are different robots, there are different prediction models that are using different machine learning approaches, and there are a majority and a variety of these approaches that exist out there to learn from the data. You can use decision tree classifiers, logistic regression, neural networks, support vector machines, k-nearest neighbors. There's so many different approaches, and there's so many different types of models that can come up in robots as well. But let's just pretend that this is just a prediction model robot pug that we're using, and we have all the patient data here, doctor's visits, medications, other data as well that's been collected on me. And this prediction model robot pug is going to use my patient data and predict the probability that I have disease D. So I'm Saniya, in case you didn't know that. So now what happens is that the doctor is running this model here and seeing, okay, well, based on all this data and using robot pug, hi Sanya, please note that you have a 4% predicted probability of having disease D. So it takes in all the patient data on me and it sort of predicts that I have a 4% chance of having disease D. So out of every 100 possibilities, 4 of those possibilities are that I have disease D. So then I'm thinking, that's me thinking over here, should I go for a treatment for disease D? What should I do? It's 4%. There's a 96% chance that I don't have the treatment disease D, so that the treatment will be useless if I go for it, according to the prediction model. There's a 96% chance I'll go for the treatment, but it won't be useful. So I said, nah, I don't think I should go for treatment. I think 4% is a relatively small chance of having the disease. I'm not going to go. No siree. Okay, so if it's a 4% chance of having the disease, I won't go for treatment. I think that a 4% chance of disease D is too low. So let's not go for it. So I'm celebrating, woohoo, yeah, woohoo, woohoo. I don't have the disease. I don't have the disease. I'm like celebrating because I don't have the disease. Ooh, let's celebrate good times. Come on, da 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 da. So I'm like really excited. I don't have the disease. I think it's too low. I'm like, nah, I don't have it, and I'm celebrating. Okay, so that was when the robot predicted I had a 4% chance of having disease D. So that's me celebrating yet again. But let's say that the risk, the robot instead says you have a 6% chance of disease. So it's a slightly higher risk than 4%. It's 6% chance. So there's a 94% chance I don't have it. So now out of 100 possible outcomes, 6 of those are that I have disease D. That's what the probability is interpreted as. Like 6 out of 100 situations, you have disease D. But 94 of them, you don't. So what should I do? It's slightly higher. It's not 4%. Now it's 6%. So, I still think it's kind of low. I say no. It's fine. I don't need to go for the treatment. And what if it's increased to 10%? Now I have a 10% risk of predicted probability of having disease D. So what I'm showing is that this model and this predictive model pug could be any model in general. So let's say that my risk went from 4%, I said no to treatment, 6% no to treatment, 10% no to the treatment. So these are the models that are giving predicted probabilities of you having the disease. And then you can decide, your caregivers or your loved ones and friends and family can decide, or your doctor can decide about this. So it really depends on your situation, right? So, for 10%, I'm saying 10 out of 100 chances I have it, but there's a 90 chances out of 100 that I don't have it. So it's still too low for me to go for treatment. And this is my personal preference. So I'll say, no, I won't go. Even if it's 10%. Even if it's 12%, I won't go. So 88% chance I don't have it. So 12% for me is still relatively low chance of having the disease. 15%, okay, now it's kind of getting up there, but I still say no. There's an 85% chance that I don't have disease D. So why go for that treatment if there's just a 15% chance of me having disease D based on whatever this model has learned? And it's taken in all my information again, guys, and it's taken all my information and it's predicting a probability that I have disease D. So now, a big emphasis. Now, there's a 20% predicted probability I could have disease D. What if the model instead says that? Hi, Sanya. Please note you have a 20% predicted probability of having disease D. So that means for every one, there's a 1 in 5 chance out of every 5 outcomes. So 20% is the same as 20 over 100, which is 1/5. So, it's 20 over 100. Which is just 1/5. So that means that out of every five outcomes, one of them says that I will have disease D. That's what the predicted probability is. Now, should I go for treatment for disease D if I have a 1 in 5 chance of having it? It's up to me, right? Like, what do I think is too high? What do I think is too low? So it's a 1 in 5 chance that I have it. In this case, I still say no to it. And what if the risk now is increased to 25%? So 25% is saying that I have a 1 in 4 chance, 25. So that means now instead of 1 in 5 having disease D, 1 out of every 4. So these are the 4 out of those. You have 4 outcomes that we can have. One of them is that I have the disease. And the other 3 are like I don't have it. But now I have a 25% predicted probability. And here I will still say, well, there's 3 out of 4 that I don't have it. It's still not high enough for me. So I say no, even if my predicted probability of having disease D is 25%. So we started off at 4% and we can see at 25%, even if it's 21% higher, I'm still saying no for treatment. What if the risk is increased to 26% now? Now something is happening. It's not so easy for me to decide on this. I'm like getting very stressed and tense. I have a 26%. Something happened from 25% risk to 26%. And suddenly it's starting to really dawn on me that I could have a really high chance of having this disease. It's kind of something happening, but I'm actually now more serious. I'm not like celebrating as much anymore. I'm not like really excited about the results. I still say no to it because there's still like a 74% chance that I don't have it. But it's kind of getting a little bit harder for me to say no. It's getting to be a lot harder to just say no. And if it risk, if it's instead the predictive model predicted that I have a 27% predicted probability of having disease D, then what's happening is again, It's getting so hard. It's so stressful. Oh my gosh, it's so hard. I don't know what to do. Oh my gosh, there's a 73% chance I don't have it, but it's a 27% chance that I have it, and that's like really worrisome. Like, what if I don't go for treatment? There's a 27% chance, but you know what? It's still, I'm just going to pray extra hard and just hope, it works out for the best. I think I'll be okay. I think that, it's okay, but it's a hard decision. The treatment, yes, maybe I should go for that, but I still kind of wish I had more, slightly stronger results. So it's kind of still difficult for me to make this decision not to go for treatment, but at the same time, I still feel like I'm almost on the edge. Like, it's now harder for me to say no for treatment. It's getting to be a lot harder, and I'm gonna have some sleepless nights. But the important thing is that when it was 27% chance, I had said no to treatment ultimately. It was a hard decision. I was tossing and turning, but I said no. But if instead the predictive model says, Sanya, you have a 28% predicted probability of having disease D, then suddenly all the stress is just like, there's a 72% chance I don't have it, but there's a 28% chance that I have it. And for some reason, this number 28 is stuck in my head. I think I really should go for treatment. It's just something about like this number. I think it's high enough for me. Just stop, stop, stop. I don't want to say no. I want to go for treatment for this. So there's something that's happening inside. And it's a electrifying moment. It's a little bit stressful. I don't know like if I'm doing the right thing or not, but I think that 28% is kind of high for me personally to take that risk and not go for treatment. I'm sweating, I'm gonna take my comfort mousse. Gonna snuggle this comfort mousse. It's getting to be a lot. The probability is getting to be way too high, and I think this is it. I can't go any, if it's 28% or higher for me, I think that's the threshold at which I'm going for treatment. It's just too high. So what happens is, to me, I'm now like really, really upset because I think this is high enough. And to me, in my mind, basically 28% is like, you have this disease. I should go for treatment, and maybe most people have like a 2 or 3% chance of having this disease or something like that. And 28% is super rare to have it. So if it's 28% or higher, so if this robot comes back to me with any number that's 28, 29, 30, 31, like all the way up to 100% chance, I'm going to go for treatment because to me, it's getting high enough. So when we went from 27, which is already very stressful, to 28% predicted probability that I have disease D, I went essentially from not going for treatment, even though that was hard for me not to go, to instead choosing to go for treatment. So something happened. It was like the 28%, that tiny nudge was the last straw, the straw that broke the moose's back, so to speak. Went from walking like this to like. So something changed, and that was that the predicted probability essentially crossed that threshold I had. From a 27% chance of having the disease to 28%, it became so much higher for me. And I think that at that point I snapped and I'm like, I'm going for treatment. So my probability threshold essentially is 28%. So any probability that's 28% or higher of me having disease D will mean that I want to go for treatment for that disease. I'm emotional, I'm sad, but I'm going to go for treatment. I'm going to get the medication, I'm going to go for all of that, whatever it takes. So I choose to go for treatment if the probability that I have disease D is at least 28%. At that point, the risk of me not getting treated if I have disease D, that 28% chance that if I don't do anything I don't get treated, I could have disease D. That risk, that 28% chance, is worse than the 72% chance that I don't have disease D. So I'm going for it because even if I don't have it, which is 72% chance possible based on this prediction model. And again, prediction models can differ in their predicted probabilities, and part of the challenge in machine learning is to choose the best one. But let's just say that this is the best one, for all of our different analysis, this is the best predictive model that we're using. And it says that, hey, you have a 28% chance of having disease D. Then I'm going to think, I'm going to take it with a grain of salt, but I'm going to think, hey, there's a 28% chance that I have it, and if I don't go for treatment, that's a lot worse than the 72% chance that I'm going for treatment when I don't need to. So at this point, at this 28% threshold, the risk of not getting treated if I have disease D is worse than the risk of needlessly getting treated if I am healthy. That's how my mind is weighing it. That's what happened when we crossed the line from 27% or even 27.555 or something to 28%. Something happened. That's my threshold. It's like when if you keep pushing, at what point will you get the result? So yeah, there are a lot of emotions, as we can see here, that have gone into account. So I'm a pretty multifaceted person, a lot of expressions. What we can see is how all these expressions come into consideration when we're talking about disease outcomes and predicting disease outcomes, and which is the probability threshold at which you go for treatment. And essentially, for me, in my mind, since my probability threshold is 28%, since PT, I essentially think I'm positive for this disease if I have a predicted probability of the disease that is 28% or higher. That is my threshold. What is your threshold? Now that's something that can really vary based on what you know about the disease, the pros and cons, some of the research that you do on it, whatever your loved ones and say as well. So there's a lot of consideration that goes into what you choose as your probability threshold, but essentially at that threshold you essentially decide to be positive and go for treatment. And usually in many decision analysis, no, in predictive model analysis, it's usually 50%. You decide you're positive if you have a 50% chance and above, and below that you decide you're negative. But in healthcare, the cost and benefit analysis is such that going for treatment and not going for treatment, they can be life and death decisions. So everything is super magnified in healthcare as well, because it's a matter of life and death. It literally is. So that's why everything is more magnified, and we have to choose a probability threshold that sort of evaluates and considers all of those outcomes properly.